When we open Star CCM Plus up, we can either hit File New or beneath that create a file. And with Purdue's method of using Star CCM Plus, my recommendation is to use serial. You can use parallel on localhost. Previously, when it was IUPUI, would use parallel on localhost, and the recommendation was to use 24 compute processes as it was a shared server. But I've noticed that using serial for me works better using Purdue's methodology to gain access to SAR CCM+. So now the file has opened, we'll just go over a brief overview of particularly this tree. On the left hand side you have geometry, so you can create new 3D CAD models within Star CCM+. This is where your parts will import. When you import a part, they'll be in the parts folder. You can also create new simple shapes within this and combine some parts together to make a composite part. And then contacts, again, very similar. You can select any parts to create a part contact. The continua folder is where you would historically do both your physics continua and your mesh continua. However, the more up-to-date methodology for using Star CCM would recommend you use something called operations, which would fall under the geometry tree once you have imported your CAD for mesh continua. So we will still do physics continua within the continua tab. Regions, this will populate once you have assigned your parts to a region. So you can have, for simple wind tunnel simulations, you'll just have a wind tunnel region or an air region, but you could have multiple regions, multiple simulations. Stopping criteria, this is how many iterations or how many steps for your iterations that you're going to run. So it will automatically be set at 1000, but if you find that you've converged at 200 or 300 iterations, then there's no need to waste all the extra time going all the way to 1000. Then we have monitors and plots, which are the next two that we're focused on. These will become more prevalent when we have our region and we are generating reports for our regions, and you can plot them. You can either plot them as single plots or multiple plots at a time, and then we'll also get scenes beneath this once we've imported CAD, or we can just create a scene here. If we want to create a geometry scene, we'll see that the scene tab opens up on the tree. Then this row of buttons has some features that are going to be really obvious to you: starting a new file, loading a file, saving, and then we're going to have playing macros if you have those set up, start recording, importing CAD, generating surface and volume meshes, running simulations. This is all to do, so as you've already seen, this is generating new scenes. This is to do with resetting the views and rotating the model, which you can also do using shortcuts and keyboard controls. This will change your view to perspective or parallel, and then going further down, creating new plots, playing animations, single steps for the animations, and writing a movie for the animations. But all of those things will be shown in more detail the further into this tutorial we go. Then we have this properties box in the bottom left corner, and as we select components, you'll see this is where we can change the properties. So if we want to change the speed from 50 miles an hour to 100 miles per hour, we can do that there. If we want to change the density, if we want to make any adjustments to anything that we selected, it's all going to be in this properties box. Then you also have the output at the bottom here, and this is going to show you what you are doing, what operations you have carried out. Now we've covered some of the basics from the main screen, let's import some CAD. So we can either go to File, Import, and import surface mesh, or we can select the button up here. I'm going to select all of these parts at once. These are from the DrivAer model. These are STLs. You can import parasolids and STP files as well. So this will allow you to import whatever unit you recall. So if you know that your CAD model was made in inches or millimeters, you can select that. Or if you know it's made in meters, like this, you can do that. You can change the surface mode and the part mode. Let's go ahead and import that. Now that our model has imported, we can see it here. We can left click on the mouse and maneuver around. If we want to move the car around the scene, we can right click and manipulate it like that. You can also see that the projection mode is in perspective, but I think we want parallel. And these are some good shortcut keys that are worth knowing. So if you want to view the side of the car, remember X should be facing the front of the car, Z should be upwards, and Y should be going out the side, as you can see there. So if I want to see the side view of the car, if I just press S on my keyboard, it will snap to the side. And if I want to see the other side, I just have to press S again. If I want to see the front, I will press F, and the back, I press F again. I want to see the top, I press T, and the bottom, I press T again. So these are good shortcuts to snap your model to view, and it's a good way of figuring out if you've imported it in the correct orientation too. If I pressed F and I got the side view, I know that I would really want to be changing that, rotating it, which we can do in StarCCM. I would be rotating it so that the X is going straight down the front of the car. Also, it's also worth noting that we can go to views here and we can say we want to snap to some of these pre-configured views. But once we've imported it, just as a check, select the ruler, the measure distance button here. Just see if we've got our dimensions correct. It's very easy to accidentally press the wrong button and import it as meters when it should be millimeters, or miles when it should have been millimeters. So we know that this model should be about 4.5 meters long, which it is. So that's good. We can also check again from the front to make sure that the width is correct. We know that's about right. So we know that's correct. However, let's pretend that the parts were imported incorrectly. So we can scale them uniformly or in one dimension more than the others. So let's say we wanted it to be 1.5 times bigger. We just put a scale factor of 1.5 in, apply it, and everything increases in size by 1.5. Likewise, if we want to get that back to the size it was, we just need to scale it by 2/3, and there we are. Again, let's double check. The measure tool, and there we go, about 4.5 meters, perfect. So if we wanted our rear wheels, if we go to the bottom view, we wanted our rear wheels to be wider than our fronts. We can scale them from the Y by a higher value. However, as you can see, that scaled both the wheels at the same time. So what we're going to do, transform, scale it back to where it was. just changing the Y. We should be able to split by non-contiguous, and we'll get one tire on one side and one tire on the other side. Do the same with the wheels. We get both the outer face of the rim and then the inner. Now, if I want all of these to be one part, what I can do is select the three surfaces that make up the wheel on the right hand side of the car and combine, which leaves the remaining three, combine them, and then I could rename this tires, rear, right, yes, and tire, rears, rear, left. Okay, so now if I wanted my rear left tire to be a different part within the parts tree, create new part from surfaces. See, that one's disappeared. We have this, we can name it part 6 wheels rear left. And then we can scale these individually. We could scale them at the same time. Then we want to translate them. So translating, we're just moving it in the Y direction. If we were smart about this, we'd measure the distance that we need to translate it. So it's going to be half a meter. So this will translate by half a meter in the Y direction. It's a bit too far. There we go. And we'll do the same with the rear right, but we'll do it in the negative. And then we have our wider rear tires and rear wheels than our fronts. And there are additional functions we can use as well. So let's say the rear left wheel was deleted. We can use reflect. So we would make a duplicate because we don't want to just reflect one and then leave no wheel and tire on this side and then have it on this side. So we'll make a duplicate. Select reflect. We're going to be reflecting it by a meter in the Y because we know that about 2 meters the width of the car. So if we reflect it by 1 meter in the Y, it won't show without refreshing or opening a new geometry scene. So let's open a new geometry scene and you'll see we've got both of our wheels back now. Likewise, if we imagine that the wheels had been created in SolidWorks separately to the rest of the car and we had used a different geometry coordinate system, and we need to rotate the wheels to get them into the correct location. It uses radians, so please be considerate of that. We can just select the axis that we want to rotate by. So we want to rotate around the X. And the wheels have been rotated to the correct location. And they are the main transformation operations that you are going to be using when you use Star CCM+. So now that we're happy with our imported geometry, we are going to create the wind tunnel around the car. So there's two ways that we can create the part for the wind tunnel. We can just create a new part shape and a block, which is probably the easiest and quickest way. Now, Star CCM Plus has special dimensions it recommends for this. So as you can see, we are going to want 6 times the height of the car, 4 times the length in front, and 6 to 8 times the length to the rear. And then we're going to need 10 times the width for the whole width of the domain. So if you already know your dimensions of your car, this is really easy to do. However, this is where the measurement tool that I showed you earlier can come in very handy. I know it's about 2 meters wide, then I know that my total width is going to need to be 20 meters. So I'm going to have to do negative 10 on one side and positive 10 on the other. So that's our total width. Then, reviewing from the top view, we're going to want 4 times the length in front of the car. So we know that it's 4.5 meters in length for the total car. So you can drag it out if you want to. Or if I know that 4 times 4.5 is 18, so it's going to be negative 18 meters in front. And then I'm going to have 6 to 8. So it's up to you. If you want to reduce processing time, I would recommend 6. If you want to ensure a higher fidelity simulation, I would go with 8. So if we know that in front of the car it's 18 meters for 4, so we could just double that, 36 plus the car's length. So we're going to go with 40 meters behind the car. And then the side view. So there's two things we need to consider with this. First of all, let's get the total height of the car. So the height of the car is approximately 1.5 meters. So we're going to have to go with we're going to have to go with 9 meters above the car. But we are going to want to ensure these tires are in contact with the road. So using the scroll wheel, you can zoom in and out. We can raise this up a little. We see that the tires are just dissecting slightly. That's probably a little too much. We can really fine tune it if we want to. That would do, that would be a good amount. So they're just going to cut into the ground plane of the domain. So now we look at that domain and we compare it to Star CCM's recommended dimensions, we can see that it resembles very closely what Star CCM Plus recommend, and this will give us a blockage ratio of less than 1%. So that's one way of creating the block, which we should rename. We can rename it as air or wind tunnel. Go with air. Another way we can do it is by going into new for 3D CAD models. So right click on 3D CAD models and do new. That will open up the 3D CAD tab here. Then we're going to want to select the plane that we want to design our geometry on. So that's going to be the YZ plane. And we're going to create a sketch. We can create a line. So that's going to go in that direction. We know that we want the line length to be 5 times the width of the car. So that's going to be 10. Good. Create another line that starts from the end of that line, and we're going to go up 9 meters. So that's in the Y. That's 9 meters. We know we want it to be a total of 20 meters across. So if we get it parallel, and then say we want this to go to -10, so with our dimensions defined using our same method as before, right click, extrude. We want to extrude 2 ways asymmetrically. So in one direction it's got to be 18, sorry, that's the wrong one, 40, and then 18. Okay, let's created the block, so we're going to update 3D CAD here. We're going to create a new geometry part. Okay, we'll see that that has created the exact same dimension block as the air. So that's 2 ways of creating the domain. One, you can just right click on parts using new part shape, or you can do it through the 3D CAD methodology too. So now that we have our domain created, I'm going to open the tree to surfaces, and we're going to split by patch. You only have to click on each patch and then rename it. So name this inlet for the front. Select the floor. That can be floor or ground. And the rear can be the outlet. I'm going to leave the sides and the top all as the same thing, but you can separate them if you wanted to have, say, the sides as symmetry plane and the top as a wall, or vice versa. That'd be up to you. Let's rename this sides and top. Then we're going to come down to Operations, select New, Surface Wrapper, select all of these parts. And then we're going to input our settings in here. We're going to do Perform Mesh Alignment. Let's make this bigger so it's nice and easy to see. For mesh alignment, and these settings are very dependent on your model. So depending on the size of your model, how accurately, how tight you want your mesh to be, how refined you want it to be, you're going to change these. Now this is very much a bit of trial and error, get you in the right ballpark to begin with, but there is going to be learning required on your half to discover the correct settings for this to be able to get your simulation running efficiently, to give you an accurate simulation outcome, but not being overly demanding computationally. Because you don't want to be running a 10-hour simulation when you could be running a 3-hour simulation. So if we leave these as they are for now, hit execute, it will execute the surface wrapper operation. With our surface wrapper completed, we are going to assign parts to a region. I'm going to create a boundary for each part surface. So with our surface wrapper completed, we're going to assign parts to region. We are going to create a boundary for each part surface. Hit apply. That will populate the region. Here we're going to quickly change our inlet from a wall to a velocity inlet, and our outlet from a wall to a pressure outlet. If we wanted our sides and top to be symmetry plane, this would be the time that we would change it. But for our simulation, we're just going to leave it as a wall. Everything else is a wall because we just want it to act as a solid. And then we're going to have a new automated mesh operation. And we want surface remesher, automatic surface repair, trimmed cell mesher, and prism layer mesher selected. And we want these settings in default controls. We want them to mirror the settings that we selected for our surface wrapper. We want our input part to be the surface wrapper itself. And then we want to right click and execute. So now if we open up a new meshed scene, we can hide surfaces we're not interested in. And you can see some issues we've run into here. Obviously the mesh itself is not refined enough, but we're also merging straight from the body of the car into the floor. So we're going to go back into surface wrapper and we're going to do contact prevention. We're going to set this as a minimum size of 2 millimeters, and I'm just going to select all of the parts because we want our parts as we imported them. So that means they're not going to jump across gaps unless the gap is less than 2 millimeters. So then we need to re-execute the surface wrapper. With the surface wrapper completed, we're then going to execute the mesh. Now that's completed, you can see that although our mesh settings are obviously need further refinement, but we've got a clear separation now between the car body and the floor. So now I'm going to play around with the mesh settings to create a finer mesh for the car in particular. And I'm also going to show you something called volumetric control and also wake refinement zone. So this is going to enable us to just concentrate within the area of the car for refining our mesh and the wake zone of the car as well. So we head back to our geometry scene and you can see that the geometry of the car actually resembles the refinement of the mesh. That's okay for now. We want to add a new block around the car, and really it's up to you to determine the size of the block for this. How big an area do you want to have volumetric control? So I'm just going to have it honestly just surrounding the car a little. We snap to the front view, we're just going to come out to the side a little, and that's going to be my region that I want for volumetric control. So we will create that block, which we will name DC for volumetric control. We are now going to go into custom controls for surface wrapper, and we're going to repeat the same in automated mesh. We want our part to be DC, volumetric control. And we want to select Customize Surface Wrapper and Custom Size here. So again, this is going to take some figuring out on your behalf. How big do you want it to be relative to the base? So that could be 10%, it could be 50%, it could be 200%. You can want it larger, it's up to you. So you're going to have to find that out for yourself. We're also going to do some surface controls here. So for components like the wheels and the mirrors, we want much finer control than, say, the whole body. And we'll name this surface control wheels and mirrors. And we'll create another one which we'll have for the body and underbody. Then we want one for the ground or the floor. And we want one more for the walls. That's everything other than the ground, basically. The controls that we want to customize are going to be the target surface size and the minimum surface size. So we're going to select them to custom. We're going to do that for each one. And then we adjust these for a percentage of the base. So I'm going to put that 50% base size. The body, that can be 100%. Target surface size for the floor, we're going to set that as 1600, and the minimum size can be 800. For the walls, it's going to be 3200 for both. For the wheels and mirrors, it's going to be 100 for the target and 50 for the minimum. Custom size for the volumetric control is going to be 400%. I'm going to change my surface wrapper. So this is going to be a lot more refined, but this is going to be much more computationally demanding. So this is certainly something that you're going to want to consider experimenting, researching, and finding out for yourself. We're going to need to make sure that the automated mesh has the same parameters. When it comes to the automated meshes, let's change my prism layer mesher from stretch factor to wall thickness. There is literature available from Simmons. You can register as a student on their forum and on their account, and I highly recommend doing that. It has their own recommendations for simulation setup, and that is a very good method of figuring out what parameters you're going to want to change depending on how your mesh generation is going. So then we're going to recreate the custom controls as we did previously, including volumetric control. So this time, part surfaces are selected from the surface wrapper. Here again, we're going to want to select the parameters that we want to change. So for us, it's target surface size and minimum surface size. And we just want to mirror what we did up here. So we can open these up and we can just copy them straight over. So 3200 for both. $100 for both of those. If you want to do this in a different tab, you can just do edit and it comes up there, and then you can just select them like that. Or if you want to control multiple tabs at once, we do edit and select have custom controls there. volumetric control, we're going to select surface remesher and trimmer, custom isotropic size. And then the values are going to be just as they were previously. Now for the body, we're going to add something called the trimmer wake refinement. Which adds a new box here. We can define how far back we want our wake refinement to be. So let's select 5 meters in this case. 60% of base. And we can choose the growth rate here. So we can make it fast or slow. So now that it has finished remeshing with my much higher fidelity mesh settings, you can see just how accurate the mesh is. I'm going to show you another trick as well. So if you want to see how the mesh looks around the car, you can only see it on the floor here, which if we hide, you can't see it all anyway. So we're going to go to, close these down, go to Derive Parts, New Parts, Section, Plane, and then we want that plane, View, New Mesh Displayer, Create, and it creates, if we go to Side View, creates a mesh view going down the center of the car. You can, of course, if you go back into this, we can say that we actually want it to start from a different location with respect to the Y. But for us, we're going to leave it straight down the middle. So we can see here, the mesh is good around the car. We have a really refined mesh right around the car, and then as it goes further away, the growth rate decreases. And we have a large wake zone where the wake mesh is very highly defined as well. And the further away from the car, the lower quality the mesh, but that's fine because nothing's really occurring in these parts of the simulation. You'll also notice that it automatically creates a physics continuum for us. So we are going to go with 3-dimensional solution interpolation. We want steady state, gas, coupled flow, constant density, turbulence. We want to select K epsilon as well. And there's further things here that you can choose if you want to, but for us at this stage, that's absolutely fine for our physics continuum models. I want to go into the models and go to the gas and set it at STP, which is 1.225. And we can set our initial conditions for the velocity. So if we want our velocity in the X to be, and if you want to change the unit here, you can click on the three dots and then change it there. Or if you actually want to, you can just type in miles per hour, for example. So let's say we want to have a look at what it looks like at 50 miles per hour. So we're going to do that, but we're also going to change the inlet magnitude to 50 miles per hour. We also need to change the floor from fixed to vector. And then we change the relative velocity again to miles per hour and 50. So everything matches up there. For this model, to make it nice and easy, we're not going to have our wheels rotating, but I will show you quickly how you can do that. So if we went with front wheels, physics conditions, change from fixed to rotation rate or local rotation rate, and then you need to calculate what the value is in radians per second. I will include a slide for this. And using that calculation, we can figure out how many radians per second these wheels need to be rotating at, and that's what we're going to put in there. But for this simple simulation, obviously you wouldn't have to do that if you were doing an airfoil or anything that doesn't need to be rotating, but for this simple simulation, we're just going to leave it as it is. Then we want to go to reports, run report. So for metrics, we want to calculate our frontal area. So we know the normal view is in the X, and we know the view up is in the Z. Then we select the parts that we want to use. Go to regions. We're going to select everything that makes up the car. So we don't need to select the floor, the walls, or the inlet and outlet. And then we can select what units we want it to be in. I'm going to leave it in meters per second. Now we know the frontal area is here. We want some new reports. If we want to calculate the force, we'll just go with drag. All you have to do for downforce or lift is change it from the X to the Z. So this is our frontal area. So we're going to put that into the reference area for drag coefficient. So we'll rename this drag coefficient. We'll rename this drag. You can name it whatever you want, perhaps drag force. Don't be surprised if you put 1 in here that you're expecting downforce, that you will get a positive or negative number if you wanted to have downforce, because if you put 1 in here, you'd actually be calculating the lift. So if you wanted to calculate downforce, you should put -1. Our reference density is the same for both, and then we need to select our parts again. So for both of these, the parts are the same, all the parts of the car. And again, you can select the units that you want, pounds, force, newtons. Reference velocity of 50 miles per hour. Select all the parts. Good. Then create a monotone plot from the report. Same for this. If you had multiple ones, for instance, let's pretend that drag is lift coefficient. So we've got lift coefficient and drag coefficient. Let's select both of them, and it will ask, do you want multiple plots or single plots? So I want a single plot, and it will plot both at the same time. I don't actually want to calculate that for this. Then what we might do, let's open residuals as well, because that will automatically open. And for this, I'm just going to run it to 200 steps. I'm not concerned if we don't converge, because this is just an example. So if I saw the drag begin to plateau at 200 or 300 or 400 and it doesn't change after that, that's a great indication. If you're going to run multiple reports, multiple simulations, that would be a great point to decide when you want to stop your maximum steps. We're going to open a new scalar scene so we can visualize things while the simulation is running. Toggle the visibility for that. You can choose how you want your contour style to be. So I'm going to go with smooth blended. You can choose if you want to display the mesh or not. Again, choose the parts. For me, it's all the parts for the car. If I just wanted to see just specifically the pressure of the wheels, for example, I could just select the wheels, select the scalar field, select pressure. There we go. And again, I can change the units as and when I like. And you can also change your max and min as well, and what color you want it to be. Then we go to 100 levels. It's going to make the transition a little smoother. But I'm also going to add, like we saw before, we go to derive parts, new part, section, plane. I'm going to do the exact same plane view as previously, but I'm going to display a vector displayer. So this will populate in our scalar scene here. Change it to line integral convolution. I want it to be miles per hour. I'm going to change the color bar to blue-red so it contrasts the pressure. And then I should be ready for my simulation to run. This is currently in perspective. I'm going to put it in parallel. And if I want to get a bit of a grasp of what's running where, I can split my reports up. I can have my drag on this side, drag coefficient on that side. These should mirror each other quite well. And then we can have the scalar scene below. And then it's just a case of hitting the little running icon up there and the simulation will start to run. So we see we've got an error there. That's because I copied the entirety of this expression into my drag coefficient report. That's not what it wants. It just wants just the value. So this is good. So we can go to clear solution. We'll clear everything. Now we can rerun a simulation. Okay, and now you can see the 200 iterations have finished. We've got a plateau here. I'll show you how you can get it so that the y-axis is smaller. So these should really mirror each other. So if I went to, all you have to do is click on the actual axis, and then you undo the lock. So if they're identical, then you can do lock maximum. And so I have a range from the minimum to 0.5. So that helps me to identify, because otherwise I'd have to try and scroll in and keep scrolling and it wouldn't be as good. Whereas it's just a lot easier to lock the y-axis. And we can see here the flow field around the car, the air velocity around the car, and the pressure distribution around the car. So we might want to change the pressure distribution field so that we can get a better idea. So we go to scalar field within our scalar scene, and we set that to minus 2,500 pascals. That's 1,500. We're going to see these low pressure regions on the tires, high pressure on the windshield, which is what we would expect. I'll show you some more post-processing functions. So we're going to move this over and get the scalar scene up here, so it's easier to just work in one scene. Again, with the velocity, if we wanted to change the minimum magnitude to 35 miles per hour, we can do that, and that will highlight a lot easier our wake zone. Change to 20. Again, you see that a lot clearer. Okay, so we go to close these trees down that we're not using. If we want the actual specific number for the drag coefficient, we just double click on drag coefficient report. It's this monitor value here. Same with drag, double click on that, and it will give the value, which is in newtons. I can change it to pounds-force, and it will do the same. So if we go to derived parts, you streamline, there we go. Line seed, display the tool. So currently, if I did that, it would create a line seed along here, which isn't particularly helpful to us. So if I go to the side view, so that's not going to change the geometry at all in the Y. Side view, I can get it kind of to where I want it to be, just sort of eyeballing it, which is fine if you want it to just be like this, or you can be more precise if you want. You can say exactly how high and what angle, do you want it to be like that. So if we had it at that angle, and then that should be right on the center line of the car. And resolution, that refers to how many lines there are. So we'll start with 20. Need to select a function for it. Go back to our scene, scroll this down, scalar scene, and we'll toggle the visibility for the velocity around the car, because our streamline is going to show velocity as well. Scroll down to velocity, select velocity magnitude. I'm going to change the color bar so it contrasts to the pressure. Okay, so I can change the widths of them here. So if I made it thicker, you can see that. I could change, got to change the units to miles per hour. And then we go on to animations. turn animation mode on to tracers, and you can adjust, fine tune your head size, delay between the tracers, etc. But just for now, we're just going to play it so you can actually visualize the airflow around the car. See this wake region. Pause that. If you want to go step by step, you can do that. If you wanted to make the tail link much longer, let's say 2 seconds, do that. Entirely up to you. So if we change, so there's a 3 delay between tracers. There's a second between. One way to visualize it. One other thing we might want to do with derived parts is create a scalar displayer using the plane view, and then that will be down here, and select the field velocity, magnitude, and we're going to use smooth blend. So just to visualize, this is automatic, which is the field, smooth field with lines, just lines, the smooth blended. I'm going to leave mine as smooth blended. Change it to miles per hour. I'm going to use clip. I'm going to do below min and above max. I'm going to change the max to 45, 30, 35. There we go. We'll see what this does. Change that to 35. I'm going to animation mode on to continuous sweep. I've already turned off the streamline screen animation from earlier. Then I hit play, so you can get some visualization there of the flow around the car, but this may require some adjusting until you get a value for the maximum that you're happy with, which will help to visualize the flow better. So if we go straight from on, we can pause it and we can go step by step to visualize it. So you can see the airflow on the front is basically stopped right in the center of the grille. You can see where in turbulent areas where velocity is low, you can visualize it, visualize the wake zone as well. So that's another good post-processing visualization tool. One other thing we may want to do, go back to get our scalar field up. One other thing we may want to do is change the background, because white is not perhaps the best background color right now. You can go with solid or gradient or checkerboard or environment map, but honestly solid and gradient is what you should be using. I'm going to go with 2 colors. So color 2 is my bottom color and color 1 is my upper color. So I can have a gray gradient at the bottom and a light gray at the top. And we can even use for our vector, we can do animations on that as well. So I have turned on, so then I can, excuse me, pulse, not continuous sweep. So if I do pulse, the airflow pulses around the car. And there are further post-processing tools that you can use to help visualize more airflow and help improve the color bar. So my text color is in black. Perhaps it makes more sense to have it in white if it's at the bottom here. And we can change the opacity and the height and the size of the lettering. But I would encourage you to carry out your own research and investigation in how you want to best do your post processing to get the best visualization for your own needs.